You can't do the question why this question is just impossible for you to be done. Okay, first let's think about there are two equations. Y equals to 3x squared minus 6x plus 1. And the second equation is y equals to 4x squared plus 4x. Okay, 4x squared plus 4x. Okay, first, like only same type of equations can be transformed to each other. And this equation is the same, are the same type of equations, so all quadratics, okay? So the graph both looks like this or this or this, so they definitely can be transferred to each other. But the thing is, the method we learned before is hard to apply to this question, because let's make the original one as xy, so y equals to that minus 6x plus 1, and y dash equals to 4x dash squared plus 4x dash. Okay, what we can see is we cannot equalize both sides. I don't know what I should equalize. Okay, I can't see the model itself. And also there are two x in one equation. Okay, there are two x. Now here is one x, here is one x. And the coefficient is different. Okay, see, like the coefficient for both x are different. So I cannot equalize both sides. I cannot apply the normal method. Okay, so I want to do something to both of them. To reduce the number of x in the equation. There are 2x now, I want to reduce it to 1x only in this equation. How I can reduce to only 1x? Very close, factorize. Something quite similar to factorize. Before you factorize, what do you need to do? Okay, think about the three forms of quadratic. What form we have? Intercept form, general form, turning point form. Which one of those forms only have one x? What's general form is ax squared plus bx plus c. Intercept form is a times x minus capital A times x minus capital B, so still 2x. What's the turning point form? Turning point form is a times x minus h squared plus k. Okay, only one x in this equation. So we'll make that into turning point form first, because I want to reduce the number of x in the equation and I want to see the model. Okay, the model, we don't have this as a model. The model can be something squared. Okay, something squared will be a model and that will be the turning point form. Okay, that will be the turning point form. So let's make that into the turning point form first. If we want to find turning point form, then 3 will be a common factor, x squared minus 2x and plus 1. Y will equals to 3, x squared minus 2x plus 1 minus 1 and outside plus 1. Y will be 3 square bracket x minus 1 squared minus 1 and plus 1. Y will equals to 3x minus 1 squared minus 3 plus 1, which gives me minus 2. And for this side, let's not put the dash on yet. Let's put the dash on later. So y equals to 4 x squared plus x. Y equals to 4 x squared plus x plus a half squared minus a half squared. Y equals to 4 x plus a half squared minus a quarter. Y equals to 4x plus a half squared minus 1. So let's say that's y dash and x dash. Okay, that's the new equation. Y dash and x dash. That's completing square. Okay, I have complete square for both of the equations. And now I want to only leave the model on one side. Okay, the model will be something squared, not including the 3 and 4, because 3 and 4 is not squared. Okay. I can only leave that on the right. Okay, I can only leave that on the right. So what I will have is y plus 2 over 3 equals to x minus 1 squared. And for the x dash, y dash part, y dash plus 1 over 4 equals to x dash plus a half squared. Why have so little space? Now I can equalize both sides because there's a model, and left hand side is all the coefficients and like dilation factors. So I can have y plus 2 over 3 equals to y dash plus 1 over 4. And I can times 4 on both sides. That's 4y plus 8 over 3 equals to y dash plus 1. Then y dash equals to 4 over 3y. Okay, plus 8 over 3 and subtract 1. Okay, subtract 1 is plus 5 over 3. Okay, you subtract 1 and separate that. To the x side, x minus 1 equals to x dash plus a half. Then x dash equals to x minus 3 over 2. Minus 1 minus a half is minus 3 over 2. DRT order, dilation by a factor of 4 on 3 from the x-axis because it's changing y. So it's from x-axis. Second, translate 3 over 2 units to the left and 5 over 3 units up. Okay, two translations, minus 3 over 2 and plus 5 over 3. Okay, one to the left because it's x side and one up and down because it's the y side. Okay, I don't have enough space, therefore I'll open this and let's have a think. Okay, let's now think about this question. We have, okay, let you finish. First we have y equals to 3x minus 1 squared minus 1. Is that minus 1 or plus? Minus 2. Okay, and then y dash equals to 4x dash plus a half squared minus 1. Okay, that's the two equations we have. Okay, and first what we do is I make y plus 2 over 3 equals to x minus 1 squared, and I make y dash plus 1 over 4 equals to x dash plus a half squared. And after I rearrange everything, y dash equals to 4 on 3y plus 5 on 3, and x dash equals to x minus 3 over 2. Okay, that's what we have done. Okay, that's what we have done. So I don't care about the translation, but it's dilated by a factor of 4 on 3 from x-axis. Okay, from x-axis. Do you remember last time when we do the square root question, I said if it can be dilated from x-axis, it can be dilated from y-axis by a different factor. There's more than one ways to do the dilation. If you can dilate from x, you can do a different factor dilate from y. And in the exam, it's possible to ask you, especially from which x-axis. Okay, it's just let you know, say there's a dilation, okay, factor of something from x-axis or y-axis given to you. So for quadratic, there's a lot of questions like that. Give you we dilate from which x-axis already. So it dilate from x. This is what from my answer. Okay, I find from x. But the question can ask you, is dilate by a factor of what? From y-axis. Okay, it will ask you, this is a dilation factor by what? From y-axis. So I don't want you to dilate from x side. I want you to also dilate from the y side. What we can do. Okay, what we can do if I want to dilate from the y side. So if it's dilate from the y side, I need to change x. Okay, I need to change x. There will be some factor times with x. You can't times the factor with y. Therefore, this 3 and 4 cannot be divided to that side. Because if you divide it to that side, there's some factor for y already. Okay, there's some factor for y already. So you can only have plus minus for y. You can't have times and divide for y. Because you don't want dilation from x-axis. Therefore, let's do this. Okay, we have y plus 2 equals to 3x minus 1 squared. Is that minus 1? Okay, y plus 2 equals 3. That. Okay, and then we also have y dash plus 1 equals to x dash plus a half squared. Okay, we have that, no, 4. There's a 4 inside. Okay, we have that. Okay, I can't divide the 3, I can't divide the 4 on that side because even though it's not part of my model, I still can't divide it. If I divide, there must be dilation for y side. Doesn't matter which one you divide. Okay, so what I can see now is, okay, this 3, okay, this 3 is annoying because it's not part of the model. The model is something squared, okay, model is something squared. So now what I can do is I change the 3 to square root 3 squared times x minus 1 squared. And y dash plus 1 equals to 2 squared times x dash plus 1, plus a half, I think, yeah? That's plus a half. Okay, plus a half squared. So what I will have is y plus 2 equals to square root 3 x minus 1, the whole thing squared. And then I have y dash plus 1 equals to 2 x dash plus a half, and then whole thing squared. Because you have a squared times b squared equals to ab times together and then squared. So I put the number actually inside the model. Okay, I put the number back to the model. So I have y plus 2 equals to root 3x minus root 3 squared. Y dash plus 1 equals to 2x dash plus 1 squared. Okay, now both sides looks correct now. Okay, both sides looks correct. So y plus 2 will equals to y dash plus 1. Square root 3x minus root 3 will equals to 2x dash plus 1. So y dash will equals to y plus 1. Okay, x dash equals to root 3x minus root 3 minus 1, then divide by 2. So x dash equals to root 3 over 2x minus root 3 plus 1 over 2. Okay, minus root 3 plus 1 over 2. That's a positive number. Okay, subtract a positive number is moving to the left by that many units. Now this is a dilation by a factor of that from y-axis. Translate. Okay, this many units Okay, root 3 is 1.7, 2.7 divided by 2 is 1.35 something, like it's a 1.3 units to the left. So you don't need to worry about how large is that, you just need to make sure that's a positive number, and you say move that much units to the left, and 1 unit up. Okay, y plus 1 unit up. Any questions? It's quite important you know both ways, okay, especially for quadratic. You need to know the dilation factor from the x side and the dilation factor from the y side. Okay, so it's quite important. It's quite important from both sides. And you can see the dilation factor change. The translation units also change. Okay, before I translate, how many units? I translate 3/2 units to the left and 5/3 up. But now I only translate 1 unit up and root 3 plus 1/2 units to the left. Okay, so the translation units change and also the dilation factor change if you change the dilation directions. Okay, if you change the dilation directions. Okay, I'll upload this page as the solution of notes together. So this is page 5, example 3. Okay, I'll upload that together with the solution. Okay, next page. Okay. I'll wait till you stop talking. I'm not going to teach. You are year 11. Okay. Okay, matrix. So I think some of you learned a little bit about matrix before. Some of you just have no idea about what is matrix. Okay, most of you have no idea about what is matrix. So we learned the basic things for matrix, the calculation of matrix first, and then we'll use matrix to help us to talk about the transformation. Okay, we use matrix to talk about transformation. So in high school, matrix will work with simultaneous equations, like linear simultaneous equations, and matrix closely. Before, we still have Markov chain, a probability topic, but it's get rid of that from the course outline. So we only work with two things for matrix. One is simultaneous linear equations, and we don't really use that much in linear as well. But we use this for matrix a lot, okay, a lot. So we need to know matrix to work well on transformation. So first, what is a matrix? Okay, you just can treat matrix as a rectangular array of numbers arranged in rows and columns. Okay, so I have 4 rows, 3 columns. So I have 12 numbers, okay, arranged in a rectangular box. You can't have that. Okay, you can't have that. You need some number here. Okay, it must be a rectangular shape, same number of rows, number of columns. Okay, so that is a matrix. Okay, matrix is just a group of numbers put in the box. What is entry? So the number in the array are called the entries of the matrix. So 2, 3, 1, 4, 5, 0, they are all entries. There are 6 entries in this matrix. Okay, all the numbers you put in is called entries. Capital letter can be represent a matrix. I can say capital A represent 1, 2, 4, 5. That A represent that matrix. We normally won't use lowercase a to represent matrix, okay? So it's all capital letter. 4, if you use capital A to represent this matrix, then the lowercase of that letter and ij is the number as subscript is referred to the element in the ith row and jth column. Okay, let's just write more numbers in this one. Okay, there are 2 rows, 4 columns, and this matrix is called capital A. Then when I say lowercase a, 2, 4, which means the element or the entry in the matrix A in row number 2 and column number 4, that will give you the number 7. Okay, in that matrix A, row number 2 is 4, 5, 7, 8, 7. Then the column 4 will be the last number, which is the 7. If I have A 1, 3, that will be the 3. Okay, row 1, column 3, which is this position here. Row 1, column 3. Okay, the dimension, or say all the size of the matrix. Okay, what is the dimension of a matrix? So dimension is how large. Okay, think about like what's the size of this matrix. It's the number of rows times the number of columns. So dimension of A here is row 2 times column 4. Okay, there are 2 rows and 4 columns. You will say 2 times 4. Okay, 2 rows and 4 columns. 2 times 4. And you won't evaluate this as 8. Okay, you just put this expression there. It's 2 times 4 matrix. You won't say that's an 8 matrix. Okay, it's 2 times 4 matrix. Won't evaluate that. Here we have matrix A. This A is a 3 times 2 matrix. You have row 3 rows and 2 columns. So row 3 times 2. It must be the number of rows in the front, the number of columns at the back. Okay, row, column. Okay, and you can say A21, which is row 2, column 1, which is -1. Okay, the element is -1. Okay, 2 matrices A and B are equal. 2 matrices A and B are equal when they have the same number of rows and same number of columns. So, same size or same dimension. If they're not the same dimension, they can't be equivalent at all. Okay, same size or same dimension. Second, they have the same number or entry at the corresponding position. What is corresponding position? So for that position, row 1, column 2, they must have the same number. Row 3, column 5, you must have the same number. Therefore, this is a copy-paste case. Okay, you copy something, paste that, those 2 matrices are the same. Unless you won't have equal matrix. Okay, you copy a matrix, you paste that, they need to look identical. Okay, looks exactly the same. Then they are the equivalent matrix. For example, let's see A and B. A and B has the same dimension. They are all 2 times 2 matrix. But row 1, column 1, you have 1 here. Row 1, column 1, you have 3 here. They are not the same matrix. Okay, the corresponding position doesn't have the same number, even though you have 1, 2, 3, 4, 1, 2, 3, 4. Okay, but they are not at the corresponding position. They are not the equivalent matrix. Okay, addition and subtraction of matrix. First, there's requirement for that if you want to add or subtract that. Only matrix with same dimensions can be added or subtracted. Okay, you need to have same dimension. 2 times 2, 3 times 4, it needs to be the same dimension. Then you can add or subtract between them. The sum and difference is found by adding or subtracting the corresponding entries. Okay, by add or subtract the corresponding entries. So what means by that? You will add row 1, column 1 from both of them. You will subtract row 1, column 1 for both of them. You will add row 2, column 1. You add row 3, column 3. So you add the same position numbers together or subtract them. Let's have a look at this example. It's hard to describe in words. Say A plus B. If you want to find A plus B, therefore you want to find, okay, let's write it clear. A plus B. So first of all, that is 2 times 2 matrix. That is 2 times 2 matrix. They got the same dimension, then I can add or subtract them. So I can add row 1, column 1 together, which is 1 plus 2. I can add row 2, column 1 together, which is 3 plus 4. I can add row 2, column 1, which is 2 plus -3. And I can add 4 plus 1. Okay, they have the same position. Therefore, the answer will be 3, 7, -1, and 5. Okay, so that is what we are going to have. 3, -1, 7, and 5. That's A plus B. Okay, because they are 2 times 2, all 2 times 2 matrix, therefore they can be add or subtract. And let's have a look at A subtract B. If it's A subtract B, is that subtract by that? Okay, first add minus first, you have -1. 2 minus -3, you have 5. 3 minus 4, you have -1. 4 minus 1 will give you 3. So that's A minus B. You have B minus A as well. So B right in the front, minus A here. 2 minus 1 is 1, minus 3 minus 2 is -5, 4 minus 3 is 1, 1 minus 4 is -3. Okay, multiplication of a matrix by a real number. So you have a matrix A is a m times n matrix, and K is a real number. This real number I can call that scalar. Okay, it's a scalar. Then K times matrix A is m times a matrix whose entries are K times the corresponding entries of A. So what means by that? If you have a scalar 3, okay, this 3 times with this matrix A. Okay, a scalar can time any matrix, okay, can time any matrix. Therefore, all the entries needs to be increased by 3 times. Okay, like times by 3. All these entries will be times by 3, and that is the result. So basically, you have like the same as that's a bracket. Okay, that's a bracket. There's 3 times a bracket, so everything inside the bracket needs to be times by 3. So it's similar to that. So it's a scalar. How to do with scalar? So example 2. If A equals to that, B equals to that, find the matrix X such that 2A plus X equals to B. Okay, 2A plus X equals to B. You are looking for X. Therefore, X will equals to B minus 2A. Okay, B minus 2A. So what is B? X equals to, B is 0, minus 4, minus 2, and 8. Minus 2 times A. A is 3, 2, minus 1, and 1. Okay, B minus 2A. Then let's is still like that. And 2a, okay, 2a. I'll times 2 for all the entries here. So 6, 4, minus 2, and 2. Okay, times the 2 inside, because only matrix can subtract matrix. You have a constant outside, that's not going to work. So you need to put the constant back. Okay, you need to put the constant inside. And therefore, x will equals to 0 minus 6, you have minus 6. Minus 4, you have minus 8. Negative 2, subtract negative 2, you have 0. 2, 8, subtract 2, we have 6. You have minus 6, minus 8, 0, and 6. Okay, so what we have learned so far, have a think about it. So we learn what is matrix, what is the entry of matrix, like all the name of matrix, and how we represent matrix, and how we do addition, subtractions, and scalar multiplication of matrix. Okay, it's a number times a matrix. Okay, it's not a matrix times a matrix, it's a number times a matrix. Okay, that's what we have learned. Additions, subtractions, and multiplications of a number. Okay, and not the last. Okay, maybe second last. Second last thing we'll learn is multiplications of matrices. Okay, the previous one is multiplication of a matrix by a real number, and the number 9 is multiplication of matrices. So it's 2 matrices times together. Okay, 2 matrices times together. This is the complex part. Okay, this is the complex thing. First, okay, when we do addition and subtraction, only the same dimension thing can be add or subtract, right? There's a requirement. For multiplication of matrix, the requirement is quite annoying because it's not same dimension. Okay, it's not same dimension. It's the number of column of the first matrix will equals to the number of the rows for the second matrix. Let's say that. Okay, if you want to do A times B, A is a 2 times 3 matrix, and B is a 4 times 2 matrix. They cannot be times together because the number of column and the number of rows for the first, second, and first, they are not the same. 3 is not equivalent to 4. Okay, then you write A in the front, you write B like in the second, A times B. Okay. So A is a 2 times 3 matrix, the number of column is 3. B is a 4 times 2 matrix, the number of rows is 4 for B. 3 is not equivalent to 4. They cannot be times together. So it's undefined for those 2 matrices times together. But let's have a think about B times A. B times A, B is a 4 times 2, A is a 2 times 3 matrix. Okay, what you can see is 2 and 2, they are the same. Therefore, you can have a value. Okay, you can times them together. So A times B is not the same as B times A in matrix. Okay, even though I know in numbers 3 times 4 and 4 times 3 will be the same. But in matrix, A times B or B times A will be totally different. Okay, totally different. Some of them, like for example this case, one you can evaluate, one you can't evaluate. Okay, if say now I have A times B matrix, I have a matrix C as result. Okay, that equivalent to matrix C. So I have a prediction of what's the dimension for matrix C. Do you know that? Yes, 4 times 3. Okay, the dimension for C is 4 times 3. Where that comes from? This 4 here and this 3 here. So the middle two, you can think about the middle two get cancelled. Okay, and what has been left is 4 and 3. Therefore, there's a row 4, column 3 answer. So A times B times A is 4 times 2 matrix times 2 times 3 matrix. They can times together. We have a result C there. And the result C will be what has been left, like 4 and 3. Row 4 and column 3. That's the result. So you will know what your answer will look like. Okay, you know the answer, what the answer will look like. Okay, now come to evaluate that. Okay, A times B. 1, 3, 4, 2 times 5, 1, 6, 3. Okay, this is 2 times 2 matrix. This is 2 times 2 matrix. Therefore, the middle two will be the same. You can times them together. Right, 2 times 2, 2 times 2. The middle two number are the same. You can times them together. And the result will be a 2 times 2 matrix. Okay, the result will be a 2 times 2 matrix. So how you will times them? Okay, that's the thing. I think that's the least thing I want to teach for this year. Okay, I can reason it, but I don't think you want to know the reason. So for the first one, we think about the row. Okay, the first one, because the first one contribute row. Okay, let's look at here. Because the result will be row 4. Okay, so the first one contribute row. The second one contribute columns. Okay, so when we come to this, we'll circle rows out first. Okay, we'll circle like that, and we'll circle like that. Because one contribute rows and one contribute columns. So you go row, row, column, and column. Okay, I will have row 1, row 2. And I have column 1 and column 2. What that equivalent to? You know you will have row 2, column 2, because we got prediction here, 2 times 2 matrix. Okay, so how do we find these 4 entries? You use the row in the first one to times the column in the second one. Okay, you use the row in the first one to times the column in the second one. So let's say row 1 will time with column 1. The answer will write in row 1, column 1 place. Okay, so this place is row 1, column 1 place. So I will write the answer here. So let's use row 1 to times column 1. So the first number in row 1 times the first number in column 1. Plus the second number in row 1 times the second number in column 1. That is your first entry. This is your row 1, column 1 entry. And then I will use your row 1 to times with column 1. The answer will be put in row 1, column 1 place. Okay, the answer will be put in row 1, column 1 place. So I'll use row 1 to times column 2. Okay, row 1 times column 2. So you use the first number in row 1 times the first number in column 2, plus use the second number in row 1 times the second number in column 2. Okay, so row 1 has been timed with column 1 and column 2. Then no use for row 1 now. I'll use row 2 to times column 1. Okay, use row 2 to times column 1 and column 2. So row 2 times column 1, the answer will be put in row 2, column 1 place. Okay, which is here. So the first number times the first number, add second number times the second number. Because it's a 2 times 2 matrices, so okay, that's here. Okay, and last thing is row 2 times column 2. Okay, row 2 go to times column 2. Row 2 times column 2, you will have the answer written in the row 2, column 2 place. So first number in row 2 times the first number in column 2, add second number in row 2 times second number in column 2. Have a think about how this number has been made, okay? It's at most, I think they will give you 2 times 2 matrix. I don't think they will give you 3 times 3 matrix. That's quite a disaster for the teachers who marking it. Okay, not for you, okay, for us. I think 2 times 2 will be alright, okay, enough for you. So you just need to know how to do 2 times 2 matrix. So let's have the answer. 5 plus 18, 23. 1 plus 9, which is 10. 20 plus 12, 32. 4 plus 6, which is 10. I think I make some mistake. Right. 5 plus 18, 23. 1 plus 9, 10. 20 plus 12, 32. 4 plus 6, well, it's correct. It's correct. Okay. That's the answer for A times B. Okay, that's the answer for A times B. And let's have a think about B times A. That's page 7. Example 3 and 1. Okay, B times A. So B times A will be 5, 6, 1, 3 times with 1, 3, 4, 2. Okay, so still 2 times 2 times 2 times 2. Where's my charger? Okay, you still have 2 times 2 matrix. Okay, still have 2 times 2 matrix. You can times them. So I will find the row for the first one and the column for the second one. Have row 1, row 2, column 1 and column 2. That will equals to, okay, row 1 times column 1, put that in the place of row 1, column 1. 5 times 1 plus 1 times 4. And use row 1, column 2, okay, row 1 times column 2. Row 1, column 2 is here. So 5 times 3 plus 1 times 2. And then we finish row 1, let's use row 2. Row 2 times column 1, row 2, column 1. Okay, row 2, column 1. Row 2, column 1 is here, and it's 6 times 1 plus 3 times 4. And row 2, column 2, which is here, 6 times 3 plus 3 times 2. This will give you 9, 10, no, not 10, 15 plus 2, 17, 6 plus 12, 18, 18 plus 6, 24. Okay, have a look. B times A is that result. A times B is that result. They are totally different. Okay, there's no connections at all. So A times B is different from B times A. Okay, A times B is different from B times A. Okay, that's your B times A. Okay, example 2. Example 2. If A equals to that, B equals to that. Find the value of A times B. Let's find A times B first. A times B equals to 3, 2, minus 1, and 1. And B will be 1 minus 1. That is a row to column 2, and that is a row to column 1. So 2 and 2 are the same, therefore I can times them together. I can find the value for that. And I will use row for the first one and column for the second one. That is row 1, that is row 2, and that is column 1. The answer should give me row 1 times column 1 will give me row 1 column 1. So row 1 column 1 is here. So I will have 3 times 1 plus 2 times negative 1. The first number times the first, second number times second, and add them. For the second, it's row 2 times column 1. Okay, row 2 times column 1. You will have row 2 column 1. So just enter that. It's minus 1 times 1 plus 1 times negative 1. Okay, so what that equals to? 3 minus 2 will be 1. Minus 1 plus minus 1 will be minus 2. Okay, so it's 1 minus 2. So that is A times B. So what is B times A? B times A will be 1 minus 1 times 3, 2, minus 1, and 1. Okay, first one is a 2 times 1 matrix. Second is a 2 times 2 matrix. The middle two are not the same. Undefined. Or cannot evaluate. Okay, cannot evaluate. Because the middle two numbers are not the same, those two matrices cannot be times together. Okay, those two matrices cannot be times together. So no value for B times A. You can evaluate A times B, no problem, but B times A, no. Okay, last one. If A equals to that, X equals to that, I want to find A squared. So A squared equals to A times A. And that equals to 2 minus 1 minus 1, 4 times 2 minus 1 minus 1, 4. Okay, itself times itself. So I'll use the row for that, Oh, first I need to test. That's a 2 times 2 matrix. That is a 2 times 2 matrix as well. I can evaluate that, and you will have a 2 times 2 matrix. And you use the column for that. Row 1, row 2. Column 1, column 2. Okay, row 1 times column 1. Okay, row 1 times column 1. So it's 2 times 2 plus minus 1 times minus 1. You know you will have a 2 times 2 matrix. So you know you will have a 2 times 2 matrix. So let's divide that into 4 parts. Okay, next one is row 1 times column 2. Row 1 times column 2. So 2 times minus 1 plus minus 1 times 4. Then you use the row 2 times column 1. You have row 2 column 1, which is minus 1 times 2 plus 4 times minus 1. Okay, first times first, second times second. Last, you use row 2 times column 2. Row 2 times column 2. So minus 1 times minus 1 plus 4 times 4. Okay, that will equals to 4 plus 1, which is 5. Minus 2 plus minus 4, which is minus 6. Minus 2 minus 6, minus 4 is minus 6. Minus 1 is 1, plus 16 is 17. So a squared equals to 5 minus 6 minus 6 and 17. And if you look at x squared will be x times x. Okay, x times x. So it's 1 minus 2 times 1 minus 2. That is a 2 times 1 matrix and 2 times 1 matrix. Therefore, the middle two numbers are not the same. Okay, the middle two numbers are not the same. So for this one is undefined. Okay, for this one is undefined because you can't times them together. Okay, that's 7E. Okay, we finish whole 7E. Okay, everything is 7E. We'll continue 7F next week. Okay, 7F next week.